Okay. Next one is a designing for safer chemicals. So the chemicals should be designed which prevents the agricultural and the marine food wastage. So most of the organometallic pesticides and weedicides are necessary. Okay, while performing uh, in the actually most of the time when we are going to consider farming, in that case, farmers are using pesticides, and these pesticides are not safe for the environment and also human being also. So we should think about that. Whatever the chemicals we are going to prepare, that should be the safe for the environment and human beings. So pesticide is also a chemical which destroy the biodiversity. Okay, so we should think about the safe products, right? Next one is design for energy efficiencies. So the energy requirement for given reaction should be minimized. It is best to able to carry out the reaction at room temperature and pressures. What is happening when we are going to perform some reactions? Unnecessarily, we are going to heat the compound. If that reaction is going to be at room temperature, then why we are going to put the heat? So in that time, we should think about the energy set. So most of the time where we should carry out the reaction at room temperature, so there is no need to use excess energy. So in this way, we can minimize the energy and use energy efficiencies. So the next one is use of renewable feedstocks. So the base renewable feedstocks are biomaterials. Petroleum products are currently in the use on large scale, and these sources are depleting. So whatever the petroleum sources we are going to use from the nature, so they sometimes they may be vanished, they may be finished, right? So we should use the renewable sources. Renewable sources means mm, just like if you use the petroleum products, they produce a CO2, that CO2 goes in the environment, right? So the pollution is going to be there. But if you use renewable resources, then whatever the byproducts or gases eliminating from the particular industry or vehicles, that should be gained by the nature. Again, from the nature, we are going to use that feedstock. So these are the renewable feedstocks. Okay. So next one is catalysis. Use catalysis instead of reagents. Most of the organic reactions are occurs by the use of reagents. And a catalyst also there, but the cost of catalyst is very high. But sometimes use of catalyst is very essential because this catalyst speed up the reaction. While using a reagent, we should wait for the completion of reaction 1 day, 2 day. Sometimes it is more than 2 days, or it also consumes some energy. But use of catalyst speed up the reactions, so it saves time, right? It saves energy, it saves the efforts conducted by the particular observer. So usage of reagent produces byproducts. One more thing is that whatever the reagent you are going to use that produces byproducts, reagent cannot be recovered. So all reagents are used in comparative molar perspectives as the reactants. Catalysts, on the other hand, are used in small quantities and are recoverable. As a result, catalysts are prepared over a reagent for conducting a chemical reaction, right? The next one is less hazardous chemical synthesis.
सर माईक ऑफ आहे तुमचा.
हा सर, आवाज नाही येत.
Okay, solve केलं. Okay, sorry. Thank you. So again, we are going to consider less hazardous chemicals. Okay. हे जे काही less hazardous chemicals असतात ना, आपल्या लॅब मध्ये पण भरपूर असतात. So we are going to use in less proportion. Unnecessary, we are going to stop the use. Whenever it is necessary, that case we are going to use, and that should be in the minimum proportion. Okay, less hazardous chemical synthesis. So in the next, that is reduced derivatization. Why the derivatization occurs? Because there are some protecting groups, some deprotecting groups. Due to this, number of steps is going to be increases. Suppose any reaction, we are going to protect that molecule. There is one step. Again, we have to deprotect that molecule. There is another step. So these steps are unnecessary, is going to be increases. And due to this, the overall yield of that product is going to be decreases. While performing these steps, there should be another reagents, another catalyst. So they may be hazardous, they may be poisonous. So unnecessarily the cost of reaction is going to be increases, and which is affects the environment, right? So we have to stop the derivatization or reduce the percentage of derivatization. Next one is a design for degradation. So that is also important principle of green chemistry. It means whatever we are going to synthesize, that should be degraded into the environment. Just like as you know the plastic, right? This is the best gift to the human being, but it is undegradable, right? Plastic is very useful, but it is not degradable due to this. So we have to stop the such synthesis of such compounds which are not degradable in the environment. So whatever we are going to design, that should be degradable, right? Then safe chemistry for accident prevention. So we have to minimize the potential for accidents. Accidents results in fire, chemical releases, and explosion. An example in the tragedy in Bhopal, maybe you may heard about that, the Bhopal tragedy on 3rd December in 1984, wherein 40 ton of MIC, that is methyl isocyanate, a gas, were released accidentally into the environment at the Union Carbide pesticide plant. The incidents occur on 1984 in Bhopal. You may heard about that. A government record says that the 50,000 people were died and hundreds of thousands injured, and unrecorded number are still suffering health consequences. So the chemicals are very dangerous, and their explosion is also very dangerous. This type of incidents occur, which still due to this there are still suffering health consequences in the people. All safety systems were inoperative at the time of accidents. So we should always consider safe chemistry for accident prevention. In the laboratory also, when you enter this, you have to always see there is a safety chart, whatever the chemicals you are going to use, and what are their disadvantages, what are their advantages. So, and the last one is real-time pollution preventions. So this is also important. Such monitoring will prevent exit of hazardous chemicals into the environment. Means real-time pollution prevention means just like as ozone. Now recently ozone layer is depleting, right? The hole is going to be increases due to the global warming, some pollution, CFCF molecules. But this occurs now at this time. What we should do? We should do. The thing is that when we are going to prepare a chemical, their safety measures also considered at that time. Okay, their safety measures also considered during that time. Okay, these are the 12 principles. We are going to consider one by one in the next lecture. Today we are going to stop here. Okay, thank you.